Hello Year 11, this is Dr. Beck with another physics video for GCSE. We're today going to look at something which is a higher tier topic only, called resolving a force. So, again, turning to our booklets. In the past, we have seen how a pair of forces can act at an angle and resolved into a single force. Now, we call that parallelograms of force. If we use a similar principle, we can actually go backwards and resolve the force to make that single force have a component in one direction and another component in another direction. Now, this is often very useful when we're considering different vectors. So the same principle means that any single force can be resolved into two forces acting at an angle. And we resolve a force, certainly in GCSE, which are acting at right angles to each other. So forces which are perpendicular to each other. Now here we've got a force diagram. We can tell it's a force diagram because at the end, if you can see, we have an arrow here and we have a key over here telling us we're going to be measuring in newtons. Okay, so below this we see this diagram, and I'll just talk to you about how that has been resolved. So here at the top we have the scale of one small square is the equivalent of 1 Newton, and we're given also an angle. We don't necessarily need that angle, but it's fine to go ahead as it is. All we need to do is look at two perpendicular forces. So these are going to be at right angles to each other. Now one of them we can just use this dotted line. The other one will have to be at the right angles to it. So I'm going to draw an angle at right angles to that. All we then need to do is say, well, okay, across this direction, what is the size of that force? And that's it. 1, 2, 3, 4, 5, 6 squares along. So what's the size of that part of that force? Well, 1 square is equivalent to 1 newtons. So 6 times 1 simply tells us that this resolved part of the force is 6 newtons. And up here, 1, 2, 3, 4, 5. Stop at 5. 5 squares gives us the equivalent of 5 newtons. What we have here then is our resolved forces. If we had two forces acting perpendicular angles to each other, we would produce this angle working at 40 degrees from this plane here. We could choose to measure that or work that out. Hopefully you realize that this is a right angle, therefore 90 degrees, and therefore 90 take away 40 gives us this. So we would say that the angle is acting 50 degrees from the perpendicular or 40 degrees from this horizontal. So in this sort of problem, we are given a force acting at an angle to a surface or a direction. We can then find the component of the force acting parallel to the surface and the component acting perpendicular to the surface. We can find the magnitudes and directions by drawing a rectangle. And the rectangle has got one side parallel with the surface and one side perpendicular. And the given force, the force you are given to resolve, is then the hypotenuse of this right angle triangle. So I could draw this in over here, the other part of that rectangle. So that would be our rectangle. This would be the hypotenuse, this force would be the hypotenuse of that right angle triangle we've used to resolve it. Okay, on the next page we have some graph paper. It's quite faint, but do your best. In each case we have a scale, and we're simply asked to find the horizontal and vertical, or vertical and horizontal components of the following forces. We've got 5 to do. So I'm going to give you 7 minutes to do that. So please pause the video and practice independently how to resolve forces. Okay, welcome back. So hopefully this once again wasn't too difficult. All we need to do is draw at least parts of that rectangle. Maybe we just need the right angle triangle. All we're doing is counting boxes, then relating it to this scale. Now this scale handily is 1 box equals 1 Newton. So we simply count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 9 Newtons. 1, 2, 3 Newtons here. That's the first example. Second example, again resolving forces. Here's the resultant force. We complete the right angle triangle. Again, we're looking at perpendicular. 1, 2, 3, 4, 5, 6, 7. 7 boxes, therefore 7 Newtons. 1, 2, 3, 4 boxes, 4 Newtons up there. Okay, that was number 3. Let's go to number 2. Here we go with number 2. Hopefully you're not finding this too difficult. Again, always a right angle triangle. This is horizontal to that surface, parallel to the surface, and then perpendicular to the surface. 1, 2, 3 boxes, therefore 3 Newtons. 2, 3, 4, 5, 6 boxes, therefore 6 Newtons. Number 4. This time it's going below, so this is something else happening. Still, the principle is the same. We're looking at perpendicular directions. Again, a right angle triangle. 1, 2, 3, 4, 5. And now the magnitude of that force is 3 Newtons. Now you may be asked, or you may be told that one particular direction is positive, so perhaps we could add a minus, because it's going below that horizontal. Minus 3 Newtons. Here, for our final one, in a similar way, a right angle triangle, the parallel component 1, 2, 3 Newtons, using the same scale as before. 1, 2, 3, 4, 5, 6 Newtons, but acting down, so I suggest we write a minus sign in front of it. Well done if you got those last two all correct. Hopefully now you understand how to resolve forces.